Hello everyone and welcome again to our channel. In today's lecture we are going to study what is Minimax algorithm. Before going to this algorithm we need to understand that Minimax algorithm is an algorithm which is widely used while playing games, especially simple games such as chess and tic-tac-toe where logic is involved. Basically the purpose of artificial intelligence, as you know, is to create machines that can compete against humans. And this algorithm is also part of this concept. Now, how this algorithm actually works? There are a few points that we need to understand first before going to details about this algorithm. First of all, this is a backtracking algorithm. It means that firstly we have to move from root towards the end of the tree or towards the grandchild nodes, and from them we need to move backward to get the required value or to identify the path that is more suitable when it comes to minimax algorithm. So here it's very important that we need to backtrack from the end towards the start. Okay, this next one is best mode strategy used. So here in every node we have number of possibilities, no number of nodes to choose from. So here always we choose the best one. You see, from B we have two, and similarly from C we have E and G, two more. And third, max will try to maximize its utility, and for is min will try to minimize its utility. What is utility? First of all, utility is the goal. It is the reward that a person can get when he finishes a game. And it is mostly in case of when we don't have just simple two values, success and lost, but we have some points, some numbers that a player get at the end of the game. Now what is mini and max? Max is a, you can say, a player who want to maximum his reward, or in other words he want to achieve the most desirable results, whereas mini is his opponent who want to minimize his reward. So that's why it is called mini max algorithm. Let's say you or I, we are max. So here I will write max. No they. So first term will be max term. Max will choose definitely which is most desirable result for himself, and after max it will be min turn. And min will try to minimize the reward of max. And then again it will be max turn. So one will take turn after another. In minimax algorithm it works. And here we, for example, we took just few reward our utilities at the end of max turn, like -1 8, -3 -1 2 1 -3 and 4. So we can see that here by turn max is the one who will play the last turn, yeah? And after this we will get some utility, some reward, or maybe he can lose the game, but he will be the last one to take the turn. And here we already mentioned that this is a backtracking algorithm, so we start from down, from the very end where we have utilities. Okay, let's suppose that max is at node D, at point D. So here what are the two values that he should choose, and which is the utility that is more desirable for him? As I mentioned earlier, that max will try to maximize his utility. So in that case, if max is at position D and he has two choices, -1 and 8, he should choose 8. More desirable for him to choose 8. Now let's move on towards E, node E. I'll place E. So at E, he has again two values, -3 and -1. So which one he should choose? The greatest one, -1 for himself. On F, again there he will choose 2, and at g4. So these are the values that Max will choose just before finishing the game. Let's move back towards min. In case of min, here he will try to minimize the reward of Max. So when min is at position B, he has two values available, 8 and -1. And at C, he has two values available, F and G. He will definitely choose the one that is smallest to minimize the reward of Max. So here he will choose -1. And in case of C, he will again choose 2, because this is less than 4. So this is minimum mini what he chose. Okay, now move more backward at the very first position, or we can say at the beginning of game. So here now Max is left with two different choices, -1 or 2. Among them, Max will definitely choose the highest value, the greater utility. So it means he will choose 2. So this is way how this mini Max algorithm works. We start from the end and then move up to very start. So here you can say that Max definitely want to get the maximum utility, which means the most desirable path for Max will be A, B, D, and its utility. Max can think about his moves logically, but he cannot predict the moves of min. So in that case, he might not get to this reward. But if he choose this strategy, from A to C, then from C to F, and then from F he get this 2 reward. So this one, he should get at least this reward, that is 2, which is definitely not very desirable for him, but at least this is what he is sure about, that he should get it when he play against min. So this is how this algorithm actually work, min and Max algorithm. Both of them try to win. Max want to increase his utility, whereas min try to minimize the utility of Max. Now we see complexity of mini-Max algorithm, that is omega b power d. Here this b is branching factor. It means how much branches at each level are available during mini-Max algorithm. Branching factor, how many branches are available, whereas d is the depth, is the level, first, second, third. Depth is also called ply when it's about mini-Max algorithm, ply. Okay, let's say that in case of, for example, tic-tac-toe game, we have like branching factor 3 and depth 2. This is what I'm saying about, this is on average. It can be more, it can be less, but on average it is like branching factor is 3 and depth is 2 when we play tic-tac-toe game. So it means we have the time complexity and space complexity equal to 9. This is also space complexity, because in case of mini-Max algorithm, they both are same. Okay. So we can see that this mini-Max algorithm is desirable when we have less number of branches and depth is not too deep. But in case of games like chess, where we say that on average at each level a player have 35 different choices. This is, I am saying about on average. That means breadth or branching factor is 35, and on each play, on average, during playing chess takes 50 turns. So 50 takes one and 50 takes another one. So it means the total depth of this game chess is 100. and we calculate this number, it's a very huge number. It means the tree will be very much wide and deep. So for in case of such games where this branches is too much, we apply another algorithm that is called alpha beta pruning, where we prune out some undesirable branches. But that is what we're going to study in our next lecture. Thank you for your time and watching this video.